Project Bhoomika. Project Bhoomika is a flood relief housing project that happened as the response to the massive floods Kerala witnessed in 2018. Kerala is the southernmost state of Indian Peninsula. It is bounded in the east by the Western Ghats, a mountain range, and in the west by the Arabian Sea. It has approximately 400 kilometers of coastline and 42 rivers flowing from the east to the west. In 2018, massive floods happened in the state. The rains that continuously poured over a few days caused havoc as it was the highest in a century. The governmental agencies, which had no prior experience dealing with such an volume of rain and water, coupled with decisions like opening up dams simultaneously, meant that we had unprecedented flooding on the banks of the rivers. It led to loss of life, loss of property, damage on unprecedented scale. You can see the slides of the debris immediately after the flood. In the areas we worked on Project Bhoomika, a housing initiative. These are some of the houses that we visited as part of the relief program first, taking medicines, food, and clothing, and then we thought of rebuilding in the same place. These are hutments, mainly temporary hutments made of local materials like thatch, sheets, plastic, etc., on the banks of water bodies, freshwater bodies, and not so far from the sea. The site Cherudana in Alapi district is only 8 kilometers from the coastline, and the specialty of the site is that there are only two areas in the world, one in Holland and one in Kerala in India, where the ground level is lower than the mean sea level. You can see the kind of hutments where these people were lived. We surveyed around 100 houses and then zoomed onto 10 houses for the sake of rebuild. We entrusted the task of surveying the damaged houses to a journalist headed by Nihala. She and a team of youngsters, architects, civil engineers, social workers, etc., visited around 100 houses surveying the damage. We gave importance to the, the factors like economic factors, social factors, indices like the number of women in the household, indices like if there were people with health issues, bedridden, autism, etc., etc. And we zoomed down to 10 beneficiaries, and the decision of building at the same place where they had their property was taken, as these are all indigenous communities who depend on the water bodies for their livelihood. Working on rebuild in the charity space. Rather than looking at it as a one-time exercise, we thought that these are moments where many people come together and pool their expertise for a common cause. We thought this should be the ideal time where we should look at making a model of design build and a process which can be replicated in regional, national level. We also thought that this should be a program we should make effort to bring in affordable, safe, and resilient homes. So, in the first phase, which is the design phase, we wanted to make it inclusive for the people involved. What happens usually in rebuild programs is that the end beneficiary who is just recovering from a natural disaster and who is dependent now on a third party agency for rebuilding their house is not involved in the process of rebuild, and the reason is cost and time. Customization is seldom entertained in such programs. Usually prototypes are repeated like cookie cutters and with sole idea to cut cost and time. And that is true too, because the main focus of such programs is to actually work around a very quick time turnaround and within specific budget. So we wanted to have an effort to look at it getting some involvement of the beneficiaries reaching halfway. The design had to be simple for it to be achieving the targets of affordability and for replicating nature. We broke down the concept of a room and a house into three simple elements: a blank wall, a wall with a window, and a wall with a door. If you look at any room, however big or complex, it is essentially these three elements repeated maybe in multiple numbers. Like a room might have two doors or two walls with windows, maybe more than one blank wall. We then standardized this wall with 9 feet width and 8 feet high in dimensions. Here you can see the grid. The, the width of the panel is 9 feet and the height is 8 feet. And it is divided into grids such that on the top you can see the window can be placed in any of the three positions. It can be replaced with a door again in any of the three positions. The thickness of the wall is only 4 centimeters or 40 millimeters. The exterior frame, the peripheral frame, is made up of galvanized pipes 40 millimeters. The inside of it, we fill it with ferro cement and create a wall panel which is composite in nature. Once we established this modular system of making a house, we then assembled a team of architects and engineering students headed by a journalist who had experience in dealing with social projects to go to the site, call up a meeting of the beneficiaries and explain them with the help of scaled models, 3D images, drawings, what are the possibilities and the possible configurations of the houses which each beneficiaries could decide to choose from. We had various options like the linear, the square, the L shape or the T shape from the same number of panels. This means that we could offer some kind of an option to the people who are involved, but without having difference in the cost or time. This was a kind of inclusiveness and involvement and participation we could give to the beneficiaries at design phase. The next decision was to have the house on stilt. The geographical location we were working in had the issue of floods not just once in a century. They have floods 3 to 4 times a year wherein the water comes in at least 60 to 75 centimeter. In 2018 floods, the water raised more than 90 centimeter, but that was once in a century flood line. So we decided to put the house on stilt at 1 meter so that we can take care of the annual floods and even make it 10 centimeter above than the century's highest flood line. The sites were not accessible by roads, which meant we had to make these elements at a distance in a place where we can have truck access bringing building materials. The elements were broken down into well rings, column footing, beams, slabs, and the walls, with most of the work carried out in a central place and then transported. These are the technical drawings of a sample module, a square module. You can see 9 well rings spaced apart and then connected all to become a composite raised platform. The columns are 1 meter in high and the grids are 9 feet by 9 feet. This is the technical detail of a wall panel where you can see that the outer perimeter frame is made up of 40 mm GI pipes. Inside we have weld mesh of 2 inches into 2 inches, and then we have 2 layers of chicken mesh on either side, and then the inside of this is plastered with cement mortar 1:5 as per standard codes to form a composite ferrocement panel of 40 millimeter. This acts as a barrier to the water which will thrust on from the side. The roof truss were also made into modular since the dimensions were standard. Bringing youth into the program. We went around the colleges of engineering and architecture and picked students who were interested in joining a socially relevant project. They had just completed their graduation and were ready to move to a site and work hands-on monitoring the precast RCC elements as well as the construction of the project. On the left you can see the team, and then the team standing on top of a slab, a precast slab, and demonstrating that it can take the weight. This also meant that the beneficiaries who were witnessing this precast construction program and instilling confidence in them that the team who are overseeing the work itself can stand on top of the slab, which was slender in nature. These are the visuals of the first set of making the precast elements of the foundation. You can see well rings being made on the top, and then you can see the column footings being cast, and then in the site the earth is excavated and the well rings are inserted. 3 numbers well rings are inserted, and then the column footings are inserted and placed in position. The whole concept of Project Bhoomika was to eliminate site work to the minimum and keep it minimum so that cost can be controlled. Kerala have the highest labor cost. The labor value of each mason is highest in the country. That means we need to have methods where we are lowering the cost of site works. Another challenge was the transportation. You can see that we had to transport the precast elements through water canals using wooden local country boats with manual and motorized boats. So the elements were broken down into the weight which can be carried by 4 to 6 people. Here you can see the country boat with the precast elements being transported and the laborers installing the rings and installing the footings in place with cast in situ concrete. You can see the wells before where they are marked on the floor before they were excavated down. The work getting progressed with the precast elements placed in the site. Now you can see the beams being placed in position. The site had no road access. That meant that we couldn't bring in small cranes or small machines which could help in lifting the elements. Cast in situ jointing of the pieces happening at the site. Youngsters overseeing the work. Now more elements are in place. You can see the corner of the platform being jointed using cast in situ with more richer mix. Slowly the platform is forming up. The columns, the rings are in place, the columns are in place, the beams are in place. Can see a square shaped platform, one of the 10 houses. Can also see the frames in the photograph. The frames for superstructure is there. Laborers are now starting to place the slabs on top of the beams. You can see the slabs being placed on top of the beams. On the side you can see the temporary housing in which the family is now staying as the construction is happening in the same place where they have their house earlier. You can see the paddy field with the waterlogged. This is non-rainy season. More and more slabs are now placed on top of the beam. Now the platform, one of the platform, the slabs have been placed on top is complete now. It is getting ready for the grouting or the edges. So another platform where all the slabs have been kept and ready to be grouted into one panel. This again some of the pictures of the yard where we were casting the precast element. You can see the young civil engineers overseeing the work themselves. They also had hands-on experience in work. They are doing the steel binding works. Can see some of the fun moments where they stand on top of the slab and then show some confidence on their own work. The transportation challenges. Can you see the transportation challenges? We had to cut it down into pieces because we didn't have motorized roads. And now we can see the galvanized piped frames being made for the wall panels, the modular elements. We had very limited facilities for making these panels. In a central facilities, we had a makeshift factory kind of a place. But on a transferable scale, if an agency like a governmental agency, a town agency, or a non-governmental agency can make a proper factory and make these panels or elements, the cost can come down and the quality can go up. On the right bottom, you can see the frames being installed onto the platform, the raised platforms. On the left, you can see the frames being installed on the platform. On the top right, you can again see the roof slowly coming on top of the platform. So the advantage of this variation, usually the roof is placed last, but we went for putting up the roof immediately after the frames were up. This meant that we could beat the monsoon. In Kerala, we have 6 months of rain, 3 months season 1 and 3 months in season 2, and then intermittent rains. So having the roof first meant that we could work underneath the roof and save times. The windows that were made in the factory have now reached the site, windows and the doors, complete in all respect. The frames, shutters, lock, handles, everything, just like a prefabricated window in wooden with the glass, is now fixed onto the pipe. You can see on the right bottom slide, you can see that the windows are now placed on the openings and installed from inside the pipe. Various slides of the windows and the doors being installed. From the top left to the right, you can see windows are now installed onto the frames which already have the pipes, the weld mesh and the chicken mesh. And you can see on the right bottom, shuttering ply is fixed temporarily to the exterior and plastering starting from inside the house. The plastering is done with a rich mix of 1:5 cement mortar as per standard code for ferro cement. The slides show the plastering of the walls happening and the formation of the walls into 40 mm thick walls. On the right bottom, you can see that now the shutters, the shuttering panels that was put for the bottom is now lifted up and the height is now increased. Slides of walls getting more completed. One by one, the houses are complete in terms of the walls. This site work could be replaced by the panels being ferro-cemented at a factory level and transported if we have road access. That will mean more effective, economic and faster time of construction. Now you can see the houses are almost complete and the panels are getting primed with the cement based primers and grouted wherever there is gaps, it is grouted. Now you can see from the left where nature had its fury, it wrecked the place, damaged whatever house they had. We as an agency, Bhoomika, came in, we made a project, we found the beneficiaries, we found the funding, we found and made the technology, we found youngsters who could involve in the project, we gave technology on an experience level by seniors, and then with lot of human effort we could make flood resistant, safe, clean, inclusive housing for 10 people. These are images of the completed house. You can see that the bottom areas are already used by them for poultry and for chicken, duck and goat. You can see goats being reared by the families. On the left is architect Abhay. and engineer Ahmedukutti, the chief structural designer, with years of experience in architecture and in civil engineering, standing in front of a makeshift house. And on the right, you can see the beneficiary getting a new safe house. Project Bhoomika is a rebuild of 10 houses, and it has a main block which has two bedrooms and a large hall which is a multi-purpose hall, and on the exterior it has a toilet block of 4 feet by 4 feet for wash shower, 4 feet by 4 feet for the toilet, and in the center a wash basin.